share the file with you. So it is just to get an idea about the version we are going to use in practicals. You can download Oracle 11G Express Edition and install. You can follow the instruction, and it's very easy for you to install in your machines. And after we can do the practicals. Until then, we can start today's lesson. So then after we be moving to Oracle SQL class environment, we'll be learning the things by using Oracle. Therefore, you have to be a bit familiar with environment. That is why I asked you to install in your personal computers, and it would be very helpful for you to get the exposure to Oracle when you are working in the industry. It would be very beneficial for you to get this thing practiced. Then you can work very easily in the Oracle environments if you are asked to do so. Today we are going to basically talk about the data integrity. If you talk about the data integrity, it's the overall accuracy and completeness and consistency of data. Right? If you take a database, your data should always be consistent and it has to be very complete. For an example, if you delete or update certain records, then the dependent records also has to be updated, right? Without having the such updates or deletes, then your data becomes incorrect, right? If you take another one example, let's say a particular person would have many accounts. If that particular person is deleted from the database, the accounts has to be also deleted, right? But when you delete an account, it does not need to delete the owner of the account. Well updated, that account is no longer available for that account holder. Therefore, integrity should always assure the accuracy and validity of data. Therefore, it is also referred to the safety of data in regards to regulatory compliance. Normally, it is maintained by a collection of processes, tools, and standards implemented during the design phase of the database. Anyway, once we design, we can implement those into our database. Discuss when the integrity of data is secure, then the information stored in the database, that is example, you can understand how data is complete and accurately stored in the database. Apart from that, data integrity also makes sure that your data is safe from the outside forces. Right? Therefore, this lesson is very important regarding the normally in terms of data validity and consistency. I think you are familiar. It will result in corrupted or invalid data. Now, if you take another one example, now if you assume you are going to do a transaction from an ATM, and if your ATM crashes or if it is not able to complete the transaction, then you may result in some corrupted data. Your total transaction has not been completed. So then your account balance would sometimes be incorrect, right? You might have withdrawn some money or deposited some money, that amount is not visible. Therefore, we should take actions to correct such situation. Normally, the integrity is expressed in terms of constraints. For an example, duplication of data can lead to loss of data integrity. So if you have duplicated records, then you may lose integrity. So one example would be if a particular employee record is added twice, then he or she may be getting 2 salary payments for a month. Right? Just assume such a scenario. Since your database is not properly implemented this integrity, by mistake, the HR department might have entered a particular person twice to the system. So then he would be getting 2 salaries, right? If it is noticed, then you can take some corrective measures, but if not, it's going to be a very problem. Not even for salary. If you just think of any expenses, any of the expenses, it can be a minor expense as well, but you lose some money from the company. Now, can you suggest any way to tackle this problem given in the example? How can we avoid this type of records, the same record being entered more than once? I think you might have heard this word integrity in previous semesters as well. Anyway, how do you try to come up with a solution for this type of scenario? Now, thinking very simple, how do you stop one record being inserted twice? How do you stop registering the same student twice? What other things you can suggest? Yes, as I told you, uh, these integrities are normally expressed in terms of constraints. So you can introduce a primary key or any key constraint to avoid entering the same data twice. If you just took only the primary key, there would be sometimes a problem. Normally, we would generate an employee number by ourselves, right? The unique number can be generated, but there's a risk. If we mistakenly inserted the same person with another unique employee ID, then definitely again there's a problem, right? You can insert the same employee, only changing the employee number, right? Because we are normally supposed to have an employee number which is a unique number, but anyway we have to generate that. But now we can think, if you come up with any unique key constraints, not only the primary key constraint, you can define another constraint on national identity card number, right? Not only the employee number, you cannot have any duplicated or replicated NICs. Then when you insert the personal details of the intended employee person, then you know for sure your personal details would also not going to replicate, right? Not only the employee ID, but also the NIC number, and you can have other, if there are some unique features, so then you can have other fields also unique, but most probably NIC number would be the most appropriate, right? Then you know for sure, even though you change the employee number, since that person is having the same NIC number as in the previous record, the system doesn't allow you to do the insertion, right? Is it clear to you? So those are very small, and you have to very well think of the scenario. We have to understand the scenario and come up with a solution, right? Just not just giving a key is good. We know it in generally keys can be applied, but not only the keys are doing this uniqueness, we can have other constraints also together to impose this integrity constraints. Therefore, you should always understand the scenario and come up with a better IT solution as you are IT professionals. We have already discussed about the business rules, and we can impose business rules to implement integrity constraints. One way of imposing integrity constraint is using triggers. We'll be using triggers later on. For the moment, I think you might have heard about triggers as well as stored procedures. We'll be looking at them later on. For the moment, you can keep in mind the triggers can also be used to maintain the integrity. When we talk about the integrity, there can be major three types. Intra-record integrity. So in this case, we enforce the constraints of contents or fields, right? So in the previous case, we used selected fields like employee number or NIC number. You can enforce constraint on content, right? Only on those fields. So those are intra-record integrity. So you have referential integrity. So here we are enforcing the validity of references between records in the database. For an example, student and marks table. When we do updates for the student table, it may refer the marks table. When we update the marks table, then it should refer the student table. Without student, we can't have any marks in the marks table, right? We do not assign any marks for not registered students, right? So it has to be referred. Therefore, we call referential integrity. Then we have other thing called concurrency control. With that, we ensure the validity of database updates in a shared multi-user environment. The typical example is banking system where you use ATMs all over the country or even around the globe. So it's a multi-user environment, and there are concurrent transactions being happen even for a second. Even for a second, there can have many transactions. Therefore, we have to always think of this data integrity. Otherwise, you will definitely end up with unordered and a mess of things in the database. Right? You will not be able to do the proper analysis on the available data. For an example, if somebody wants to check the bank account balance, you would not be able to do that. Even that simple thing cannot be done if you do not maintain the integrity. Right? Therefore, it is very important regarding the database. Right. Then, integrity constraints are the things we wish to impose in order to protect the database from becoming inconsistent. The result of not having integrity constraints could be becoming inconsistent data in the database. Right? For another example, the one student may be referring 5 subjects, but in the subjects table, only 2 subjects is updated. So the database is inconsistent there. Right? If you are referring 5 subjects, then all the places, the same concept has to be maintained. It has to be visible. Right? Even in the exam table, marks table, everywhere, there should be 5 subjects related to that particular student, right? So the whole story has to be completed. We can find 6 types of integrity constraints supported by SQL. We can have entity integrity, as we have already discussed about the primary key, and not null. So having entity integrity, you can define a particular field as a primary key. Once you define a particular field as a primary key, the SQL engine does not allow you to have multiple replications of the primary key. You can't enter the same value twice, right? And you can impose not null field. Once you define the primary key, definitely it would automatically becomes not null. But for other fields, you can specifically say it's not null, right? For an example, we know the name of a person is not going to work as a primary key because the same initials, first name or last name, can be found in many persons under name. Therefore, we know it's not going to be a primary key. But to register a person or a student in a system, we know he must have a name, right? We do not find any people who is not having a name. Even a nickname is used to refer that person, right? Therefore, we have to make that field as a not null field. Otherwise, you would enter only the primary key and you can left the name field as a blank one. Then there is a problem. Therefore, you can impose this rule, the entity integrity rule, not null, to avoid maintaining null values. And the other thing is, if you insert some null values, it's again going to be same value for 2 records, right? So even if you take the value 0, now if 2 records are having the value 0, then 2 records are same. We cannot uniquely identify those 2 records, right? The null is to show that there is nothing, right? In mathematics, we represent 0 to give the idea that there is no value. For other types of data, we represent that using null. Therefore, even you replicate the null, then it is going to be a replication, right? Then we have other type of integrity constraint called referential integrity. So it comes with foreign key. So actual key is in another table or the parent table, and you refer with that key in another table. That is why we call it foreign, right? If you take foreign exchange, that is why we refer it is foreign. It is a currency in another country, but we refer that currency here to do transaction. The US dollar is a typical example. The origin of US dollar is in USA, but it is a foreign exchange for us. Right? In the same way, the original key is in another table. We use that foreign key to refer some other table's data. If you take one example, student and marks. So you can have the student ID in the student table, and you use the same student ID to refer marks of a particular subject in marks table, right? So then you refer those two tables using the foreign key. Then you can have some other fields like required data. It's again going to be a not null one. So if it is a required field, as I told you, name of a person, age, those are sometimes required fields. Therefore, you have to accept those values. Otherwise, if mistakenly somebody did not enter, then there would be a problem and it leads to inconsistent database. Therefore, we can define that field as a required field. So required field can be imposed using not null. Then validity checking, you can check whether a given data is in the given format using validity checking. So you may ask to insert some text data, but you might have assigned strings or what is a numeric value. Then the other type of integrity constraint is business rules. We have covered business rules in one of our previous lectures. Anyway, these business rules can come in two forms: assertions as well as triggers. We'll be looking into that later. For the moment, you just keep in mind these business rules are having two flavors, like assertions as well as triggers. Then you can have other type of integrity constraint, that is consistency. To do that, you can use cascade, restrict, set null, likewise. Do you have any idea of using cascade in your databases? Have you used this word cascade? I think you should be familiar with that word. You might have heard this word in previous semesters. Why you use cascade? Normally, when you do updates as well as deletes, you can use this cascade option. When you use cascades, you can, when you delete a parent table, that particular referred tables has to be also updated. When you delete a record from the parent table, the cascading is like a top-down approach. If you do any alteration for the topmost thing, then your dependents should alter accordingly. If you delete a personal bank account holder, then there should not be any accounts available on the accounts table, right? In the same way, if you do any alterations to the bank accounts, so it should also be visible in the account holders table, right? Both has to be mutually understood when we do the consistency implementation. So you should have heard about on delete cascade, on update cascade. Likewise, we can define when we create tables what are the constraints to be imposed on that particular table. In the same way, you can restrict inserting some values, and you can set null to some columns. Likewise, you can do such thing when you want to maintain consistency. But anyhow, you have to understand the scenario and give the best solution, right? You should not just use these constraints if those are not required. Therefore, you should understand anyway, in general, the primary key and not null constraints are almost all the tables are used in general database implementations, even the foreign key, but others normally we have to think and implement if it is really required. The features are given in the SQL. Then we'll quickly look at the integrity assertion. So here we told business rules can have two types of business rules in the form of assertion as well as triggers. The assertions are predicate expressing a condition that we wish database should always satisfy, right? If you take this example, it's a typical example of assertion. Or if you take this one, assertion, you have to first get the idea. Assertion is a predicate expressing a condition. It expresses a condition that we wish the database is satisfied. The condition which our database always satisfies. Now you go through this example. The sum of all loan amount for each branch must be less than the sum of all account balances, right? It's obvious now. If the balances of the accounts are lower than the given loan amount, then it is not going to work, right? Then you have to buy some money from another organization to give the loans, because you can't rotate the money, existing money, because you do not have sufficient money there. No? Your loan amount is very high than the amounts in the bank accounts. Therefore, we should maintain this type of assertion. So with that, we know this condition has to be satisfied for the database. Now, this is a typical example. This is how we normally create an assertion. using create assertion and assertion name. First you get the idea what this is going to do, then you can easily understand. You have to understand the scenario, right? This is the syntax as given in the SQL to create assertion. You may just look at it at a glance, but you have to first understand why and what we use assertion. Then we do this exercise. So you can discuss. I'll give you some minutes. You can discuss the advantages and disadvantages of using assertions to define constraints. Right, let's discuss the answers. What are the disadvantages and advantages of using assertions to define constraints? It's better you try this. So there are some sample answer. The advantages are flexible. Constraints can be changed independently. Or same constraint can be used for several transactions. If you take the disadvantages, it's a bit difficult to implement the assertions efficiently, and integrity subsystems have to be quite complex. Therefore, depending on the situation, you have to select assertions by studying the scenario. Right. Then we go to the next one, exercise. So you just take this exercise into your notebook and try to come up with a declarative integrity constraint in form of an assertion to ensure that groups classified as reference cannot be borrowed. So you can quickly try to do this. It's a typical scenario. This is how you normally, given the scenario and in the industry, you should understand whether to come up with assertion, trigger, or how you come up with a solution using integrity to a given scenario. Right? Okay. Now you quickly try this out, then we can discuss. Right. I hope everybody has attempted the exercise. What about your answers? How did you come up with the integrity constraint for this description, this scenario? So this is kind of sample answer from course. So first you have to decide what type of constraint has to be imposed. Then you can create an assertion using this type of check and non-exist, or depending on the scenario, you can check for non-exist, and you can select the book copy in this manner and check whether it is greater than 0. Likewise, anyway, you have to come up with assertion depending on the scenario. Therefore, you should be able to give your own solution when a description is given to you. Then we go to triggers. I hope you are familiar with triggers as well. Have you heard about triggers in previous semesters? And if you do not have any idea about triggers, have you any idea regarding functions or stored procedures? Procedures are same like functions in other programming languages. In the same way, the intention is bit different from stored procedures to triggers. Stored procedures can be used to call certain instructions again and again, right? For an example, to get the total number of student out of a student registration table, you can come up with a stored procedure rather than you writing select all count from the student registration table. You can have a stored procedure written and saved in the database. Whenever you want to do that query can be very lengthy, right? There can be many instructions as well as statements within the query as well as what you want to get. Then you save it as a like a function which is called stored procedure. Then you can recall that every time you want to perform the same operation, right? But triggers are somewhat different. Triggers activate automatically, but stored procedures you have to call, otherwise it won't activate, right? Triggers are activated automatically without your intervention. So once a particular condition is satisfied, it automatically activates and do the instructions specified in the trigger. So you have to always keep that in mind. So then we have to have specific condition under which the triggers to be executed. For an example, if the account balance is lower 100 rupees, you should not be given the chance to withdraw money. Normally in several banks, they hold 100 rupees in the account, which is actually deposited as a fixed value. You will not be able to withdraw that 100 until you totally close the account and withdraw all the money. So that in that case, the system should always keep on monitoring whether the transaction is going to withdraw money which is lower than the required minimum of account, right, to be maintained in the account. Therefore, you can come up with a trigger whenever statement to withdraw money is written to the database. It keeps on monitoring whether that transaction is going to withdraw money which is below the minimum account. Then you can ask the system to perform whatever the action to be taken, right? So definitely it should be avoided. You should not be allowed to withdraw money, and it can be notified to the user by a relevant message or whatever it is. Likewise, you can set the triggers to automatically activate and perform some operation. So this is the second way of implementing business rule. So we look at one example. So you quickly go through this slide and you can understand. As I told you, the allowing some negative amount in the bank account balance is a problem, right? Therefore, we should always maintain it in a positive side, as well as some banks maintain minimum account to be held within the bank, otherwise the account is not valid in their system. Anyway, depending on that business rule, that is the important thing. Depending on that business rule, they have to come up with a trigger to maintain the integrity throughout the database. Therefore, these are typical example scenarios: setting the balance account to zero, creating a loan in an amount of the overdraft, giving this loan a loan number identical to the account number of the overdrawn amount. Likewise, you can decide what to do. The condition for executing trigger is an update to the account relation that results in a negative balance value. If the account is going negative, then you can quickly check whether it is below the zero and let the trigger to activate. You can specify the condition in that manner, then the trigger will automatically activate. Is it clear, the concept? Is the concept clear to you? It's not that much hard, right? Now here's an example of code snipped of a trigger. So you can just go through. Do not worry on syntax. For the moment, you just get idea. This is the way we can implement a trigger to a database. When you do practicals, you can create very small triggers and observe the behavior, right? Therefore, it would be better if you can install Oracle 11G Express Edition by next week. Most probably you would be able to do some practicals. The other thing, even if you want to practice the environment, it is a best option to install and have it on your personal computers. It's anyway lightweight. There are other newer versions as well, but for the moment we can manage our work with 11G. One thing, when you install this Oracle Express Edition, at the end it would ask you a password to Oracle, so you can give any password you can remember, right? So you better note it down in a place where you can easily refer and give that password, and it is your own password to the database. That is the only thing you would sometimes confuse. Other things, you have to just click on next and continue the general instruction as prompted in the screen, right? Now we look at required data field. In some attributes, as we discussed, it should always contain some value. Therefore, we cannot allow to have null values, or it cannot be blank. For example, every employee must have a job title. Then likewise, every person should have an age, NIC number, likewise anything you should have identified as cannot be empty. You can impose the rule. It's a required field. Then you can impose that using not null. Then the user should always insert some value. Then you can have attribute domain constraints. Normally, every attribute has a domain, that is a set of values that are legal for it to use. For an example, you can use to denote the gender as M for male and F for female. The domain is gender. If you use M for male in the column called gender, then it can represent the males. This is to actually save the space, right? If you can limit it to one character, then you can limit millions of characters actually, right? Now, just assume for a month you are going to get millions of records. Let's say 1 million, then 2 into 1 million means 20 million then. Right? If your field is populated by 2 characters, then you need 2 million characters actually, the count. If you take count, then 2 million characters. If you use 3, then 3 million. The multiples of the character into number of records. Therefore, even removing or ignoring one character would be a much benefit to save the disk space. Therefore, we can use this type of attributes, domain-specific attributes, to reduce the storage in the database. Then we look at entity integrity. So it is basically built on top of primary key of any entity, and it must be unique. And once it is defined as primary key, it cannot be null anyway. And we normally define on a column or set of columns, that is our key, and specify that each row in the table can be uniquely identified by that value in the key. It can be a composite key or unique key, whatever it is. You have to understand that depending on the situation, and you have to come up with the best to the given scenario. Then the referential integrity, as we have already discussed, you refer another table with having the key in another table. So the typical example is the order ID in the dive item relation refers to a particular dive orders item. So that item must exist for referential integrity to be satisfied. If the item is not available, you cannot have the order. That is the main idea. To deliver the order, you should have the item in the item table. Always it has to be referred. When you place an order, you should refer the items table to check whether the ordered item is available. You cannot sell any item which is not in the item table. You cannot place any order for the items which are not available in the item table. The referential integrity options has to be declared when you define the tables. In many systems, however, there are many issues having to do with how particular referential integrity concerns are to be implemented to deal with insertions and deletions of data from parent and child table. I think you know, when you delete from the parent table, it has to be deleted or updated in the child table as well. As I told you, when you delete a record from the account holders, then the accounts table also should update that. Otherwise, you have some data which is not referred by any of the tables. Right? It's like a garbage valley. Then you waste your storage as well, and you have the problem when you query, you can't find such data available isolated in the table or the database. Therefore, we should have insertion rules. When we implement such insertion rules, a row should not be inserted in the referencing or child table unless the record is available in the matching or reference table. And that is why we refer in order to have an order, that item has to be in the items table. Anyway, inserting into parent table should not cause referential integrity problem. Right? It's obvious. Now you can alter the items table without changing the orders table. But if you want to place an order, it has to be in the items table. That way, we has to maintain. It's a natural thing. Anyway, the items table can be independently altered. But there are situations like banking accounts. If you change the parent table, if you delete a record, then the referred table, the referencing table has also to be changed. If you delete the account holders detail from the registration table, account holders table, then your accounts table should also delete the relevant records. That is for deletion. Right? That type of things are for deletion, but insertion most probably managed by the system, because normally we do not have such constraint when inserting. In this case, a row should not be deleted from the reference table, that is the parent table, in this way from the child table, but in here from the parent table, if there are matching rows in the reference, you should not just delete. If you are doing so, then it's a problem, right? That is why we should implement the tables in a proper way. Right? If you just created some table, then this thing is not going to work. Right? You can just delete from anywhere in any table. Then your database will definitely become inconsistent. Right? That is the risk. If your data is inconsistent, then you can't find actual data. You may not be able to check your actual account balance either. It may have some value, but it is not the actual value. You cannot recover that. Therefore, we use 3 ways to handle this. First one is to restrict. If you do restrict option, then you are not allowed to delete from the parent table. Right? Once you write the statement to delete from and so on, then your statement would not work if you have restricted. Another thing you can nullify, that is when you delete a record from parent table, you can reset the foreign key in the child to some null value or dummy value. Let's say if it is a numerical value, you can reset it to 0. If it is not a numerical value, you can make it null. That is one way. The other thing is to use cascade functions. As I have already mentioned this cascading thing, you can ask the system to delete all rows in the child where is a foreign key matching the key in the parent row being deleted. So if you take one example, if you delete the account holder of a particular bank, then all the accounts created under him has to be deleted. Otherwise, there would be accounts which is not owned by any of the account holders. There is no account holder. Then the accounts are isolated. To avoid that, you can set the system to delete all the records in child tables if you delete the parent table, the parent record in the parent table. That is the deletion rule. That are the 3 basic deletion rules to maintain integrity. So as we have already discussed, this referential integrity is implemented using a foreign key. This can be implemented using external programs that access database. Normally, newer database it implements executable rules or built-in integrity constraints, which you can find in databases like Access and Oracle. Then we look at the enterprise constraints. We have already discussed this in business rules. Enterprise constraints are coming in the form of business rules that may affect the database and the data stored in the database. If you take one typical example, if a manager is only permitted to manage 10 employees, then it would violate an enterprise constraint to manage more, right? It depends on the business or enterprise. That is why we call it enterprise constraint or business rule. But if you take 2 organizations, you cannot find exactly the same business rules. Right? If you take one typical example, or almost the supermarkets is using their own way of business rules. Right? All are having promotions, but the way of promoting and their business operations are different from different organization to organization. Then we look at data and domain integrity. Anyway, this is normally handled by the database. To do that, you can define a table in this manner. You can create a table name. You can come up with a set of attributes, and you can restrict null values using forbid null values. You can also use this check option to verify data which meets certain criteria, and you can set the default value for identified field. You need to think of how to to set the default value, whether it's going to be a null value, 0 or any other number. It has to be understood by you depending on the situation. To continue with the referential integrity, normally we define referential integrity on a column or set of columns in one table. Right? With that, we can guarantee that values in of the key matches with the values in the key in the related table. The key is in one parent table and it matches with the values in the key of related or foreign table. So you can come up with a referential integrity in that manner. So you can create a table with a table name. You can define the attributes as you require. You can define the primary key and optional attributes, and you can define any attribute as a reference to one another table. So this has to be on a table name, then your table name and the attribute name, and you can define the delete options, on delete, what to do. You can use the options which we discussed previously. So deletion rules can be used to implement that. First one is the restrict, nullify, or cascade options. You can do these type of things when you do the practicals, but this is only theory. Then we look at the concurrency control. Anyway, if you take the term concurrency, it allows multiple users at the same time. They are accessing the database. With that, we must assure that the transactions are serializable and they are isolated. I think you have not transactions, so you should not worry about the transactions, but you can just grab the idea. If we do concurrency, then we have to have a mechanism, even though they are happen at the same time, the result should come as it happened one after the other. Right? That is the main idea. That is why we need serializable. It happens serially, not parallelly. If you do the transaction one after the other, then there will not be any problems, right? Doing that in concurrently is the problem. So when we do one transaction, then another one is also accessing the database and doing the modification. That is the problem we have in concurrency. Therefore, we have to come up with a mechanism. The result of having the concurrent situation, the result of the final set of transaction has to be as it happened as a serialized environment, one after the another. So that is why we call isolated. If the transactions happen in isolation, then definitely it happens one after the other. So that is the concept we have to maintain in concurrency control. It is intended to handle several problems in an uncontrolled environment. So one thing is lost updates. If it is a typical thing, now you can just imagine a typical example. You may open up a notepad and open many instances of the notepad. If you double click on Notepad, then definitely it would open new instances. Right? Therefore, if you open many instances and you can write different things on different instances, and you are now going to close each instance. All the instance would ask to save the content you have written, right? It's a typical thing you even now you can do. But at the end, what remains is the last thing you saved. Other things would get overwritten by the last one, right? Therefore, in the same way, when you do concurrent accesses, you can lost some updates, and the other thing is you can have inconsistent data stays during the access, and your updates would be incompleted. Those problems would arise if you do not properly handle the concurrency control. Now you can clearly see something happen here. Now carefully go through these statements. Now assume here no concurrency control, right? This is a typical example for lost updates. Now assume John and Marsha is going to do these two transactions. If you follow the order carefully, first John starts, read the account balance, assume account balance is $1,000. In the meantime, Marsha is also reading the account balance of the same account. Now she is also looking the account balance, and she is also getting the same amount. Then John tries to withdraw $200. Now he is going to withdraw from 1,000. Therefore, 1,000 minus 200 is 800. Since Marsha also saw the amount as 1,000, is going to withdraw 300. Then from 300 out of 1,000 is 700. Now at this point, you just assume, because if this is properly handled, once John withdrawn 200, that value has to be visible to Marsha, right? Therefore, not having the concurrency control introduces a lot more issues to databases. Then John commits this transaction with 800 in balance, and Marsha also writes account balance as 700. Now altogether, even though 800 and 700 are result of deducting money from 1,000, actual balance has to be 500, because John has withdrawn 200 and Marsha has withdrawn another 300. Then the update is not visible in this transaction. It is lost. Right? I think you can clearly understand the risk of lost updates, where this can happen to you if the concurrency is not handled in banking systems. Is it clear to you? Now we concurrency control using locking. You can introduce locking mechanism in different level, from database level, table level, lock on a page or record field or whatever it is. Then you can have shared locks as well as exclusive locks. There are two types. Now you assume first, when John is going to do the transaction, the system locks the account balance. Right, then Marsha cannot read. The read account balance is denied. Right. So John performs his operation and writes the account balance. Once it is totally completed the transaction, the system unlock the account balance. Right. Now Marsha is trying to check the account balance. She is waiting until this operation completes. The waiting means there's not wait hours of time. This is split seconds, right? This happens within split seconds. So you will never even notice that, right? This type of thing happen. This is happening that much fast. Therefore, first this is unlocked and then allow the Marsha to read, and she reads the account balance. Then she's getting is at 800, and she is doing the transaction, and it is completes as it happened individually or in isolation. So this has been updated with exclusive lock, right? That is mentioned by XLock. Then if you use locking mechanisms, then there can be deadlocks as well. If the lock is shared by two different parties, then releasing the lock is a problem. If one to release the lock, the other one also should release the lock. That is what we call deadlock. None of the parties can release their locks. In shared lock environment. So here's a typical example. John is having a shared lock. So he's going to read the balance. And meanwhile, Marsha is also having a shared lock to read account balance. Then John needs to request a XLock, that is an exclusive lock. It is denied by the system because Marsha is also requested a shared lock. Having the shared lock, John cannot request exclusive lock because another one is also having the authority to do the transaction, because this is in shared lock environment. Then John has to wait. Again, to complete this transaction, Marsha also needs to request an exclusive lock. Now, think on this scenario. John needs exclusive lock. It is denied because Marsha is having a shared lock. Now, Marsha is requesting again exclusive lock. It is also denied because John is also having a shared lock. Right? So each of them are waiting. There's no ending of this type of scenario. So this is called a deadlock. Even in roundabouts, you may see if the color lights are not operated properly, then we cannot move any of the vehicle because it is blocked by each other. To release one, the other one should move. To move that person, another one should move. Likewise, each other is scrambled and we cannot move any of the vehicles in that situation. In the same way, then here the blocks are not released because each other's keeping also. Therefore, in concurrency control, to avoid deadlocks by maintaining tables of potential deadlocks, and we need to backing out one side of a conflicting transaction. Therefore, we have to have that type of mechanism. Otherwise, we cannot avoid happening this deadlocks. If deadlocks happens, the system waits without any response. So there can be found some rules associated with referential integrity. As we have already discussed, you can have restrict access, set to null, or set to default. We have already discussed these things in previous slides. And rules associated with referential integrity can also be cascade, as we have already discussed. And you can do no action. So it disallows the updates or deletion of reference data. Actually, this is different from RST because it is checked at the end of the statements or at the end of the transaction. Anyway, in Oracle, it uses no action as its default action to maintain rules associated to referential integrity. Depending on the database management system, they might have decided different ways of maintaining the referential integrity rules. In Oracle, no action is the default one. Here are the integrity constraint descriptions. Not null constraint. These are rules associated with null values in a column. And you can have unique key constraint and rules associated with the unique column values. As I told you at the beginning of this lesson, you can have a primary key as well as unique key. So the primary key most probably is a generated one, but you cannot come up with the unique key with existing attributes like NIC number, and to avoid replicated values and to make sure that value is not replicated, then you can assure you are having only one such record in the database. Then you can come up with integrity constraint description, and foreign key constraints, as we have already discussed, and check condition or check constraint for complex integrity rules. So these are the advantages of integrity constraints. Easy to declare or implement. Rules are stored in the centralized location. Easy to manage when business rules were changed. immediate user feedbacks, and in performance wise it is very high, and flexibility for data loads and identification of integrity violations. So if you have properly implemented these integrity constraints, then you can benefit in these ways. Then you can have some idea of non-rule example. So here, first you carefully go through the slide, and you can understand with the example. The first employee name column, it is defined as not null constraint, so no row can contain a null value for this table under this column. But in the second the column, the last one before the column is not implemented using none value. Therefore, you can have null values. Or you can see for the first record, there is no value inserted. Here are some examples for unique column example. Here, apart from the department number, dname is defined as unique key constraint. Then no row can contain a value in the constraints column. Now, if you try to insert the value given in the latter part of the slide, if you try to insert 50 sales into a department table, so then your New York would violate the unique column or unique key constraint. Then it will result in an error. Also, the second one violates unique key constraint because it is going to insert some null value. First one violates because sales is already in the dname column. So once you have defined unique key constraint, you cannot have duplicate values. Then here's an example of composite unique key. Composite means a combination of several attributes. Composition of several attributes form another key. If you take one example, to validate a phone number, you may first use the country code and then the mobile telecommunication provider's code and your number. The type of things. So composition of telephone number is composed of those three things. Right. Then primary key. I think almost all of you know about the primary key. Then once you define the primary key, you cannot have duplicate values and it cannot be null. Then you can look at this example of referential integrity where the foreign key comes into play. Therefore, you have the parent table called department and child table employee. Then employee department number is referred in departments, department tables, department number. Therefore, when you try to insert the record of 7574 Ford manager, that particular set of values to the employee table, it violates the employee number, employee department number, because the Ford is not available in the parent table. Therefore, you are not allowed to insert this statement into the employee table. Then you can have the referential integrity on a single table as well. This is a typical example for that, where here the manager is again an employee, so to insert manager, it has to be under employee number column. Right. Now we'll look at the consistency. So we will be looking at this concept of consistency. Previously we looked at integrity. So consistency should always focus into one place. With that, we can get the uniqueness of data across the database. For an example, if employee name is repeated in many tables in the database, in every place it should appear as the same name. Right? Now if you check, you may have several accounts in a bank. All the bank account details should display your name as how you refer in your passbook or whatever, what the name you have given to the bank, right? So in one place one name, in another place another name is not actually accepted in banking system, right? Therefore, you should always maintain that uniqueness. When you duplicate data, there can be many problems. Then it's a risk to and it leads to inconsistent data. Therefore, by eliminating or controlling redundancy, we reduce the risk of inconsistencies to be occurred. That is why we should always think of controlling the redundancy. Now, look at this example. Some data can be available in many places. For an example, employee name can be repeated in many places, in employee table, department table, and payroll table. This is repetitive data and is of no use. In systems, if you take the transaction for a month, it can be millions. Then if you duplicate your name in two different places, then you have to multiply by number of transactions. It will be a very problem then. And if you properly normalize these databases, once you have finalized the ER diagram, then you can definitely come up with a better structure of tables to reduce the duplicate values, values. Therefore, normally we store only data in one table. That same data is not stored in any other places. If you take the same example of this referential integrity thing, so we have a department table. Here the department name is stored in the D name, under D name. It is not going to store again in the employee table. But we have to refer this value in both tables, so therefore we have that column into a key, and it is only duplicated. Only that column is going to duplicate in both the tables, not all the rows or the records. So whenever it is controlled, redundancies allowed. The redundancy is needed, but it is controlled. All the records are not redundant in an ad hoc manner. So here one example how we can eliminate data redundancy. As I already shown you, this is again another example. You can create redundancy using this referential integrity. You can have table as well as book table. You can redundant only the author's ID. So it is a single or multiple, only several characters. Only that data is going to be redundant. So you minimize the redundancy. Therefore, we maintain only author's details only within the author's table. If not, we may need to redundant data in all the tables. As example, in here, employee table, department table, payroll table. If you are to replicate, then we have to replicate in all the places. Then we can make a join out of these two tables and try to display all the books written by a particular author. Then if you look at the constraints regarding the consistency rule, those are not permitted to violate. It may apply to data items within a single record or relationship between records. Therefore, you can implement business rules as constraints. Then you look at integrity, independence. So integrity constraints that are specific to a particular relational database has to be defined in the relational database as a sub-language, and it should be able to store in the data catalog, not in the application program. Right? I think you know the data catalog. In data catalog, we store these things, and integrity must be independent from the application program. Right? Therefore, you should not allow application program to handle this integrity. And a sub-language is one that does not attempt to include string means. And the relational algebra and relational calculus can be thought of as sub-languages. I think if you are not familiar on relational algebra and relational calculus, you should not worry about that. This is only to give you some idea of how integrity independence is. And do you have any questions? If you do not have any questions, you can quickly just look at the database implementation using PLSQL. In SQL is an abbreviation for structured query language. It is used for accessing and modifying information in a database. Normally, you can have common SQL commands like create, insert, update, and delete commands. Apart from that, you can do many other operations using SQL. I think you are familiar with SQL in previous semesters. However, in Oracle, it uses something called PLSQL, which is referred as Procedural Language SQL. It is an extension to SQL with design features of programming languages. Therefore, you can write conditional statements, loops, iterative constructs like loops, and different functions likewise which are available in the programming languages. And PLSQL is part of the Oracle Relational Database Management System. Therefore, it is very important to use this database management system because many of the Fortune companies are using this type of databases because due to the higher licensing fees. Other database management systems like DB2, which are also very higher in licensing fees. Most of the companies, the Fortune companies are using, but others has to be on small database management systems due to the licensing fees. So if you check why we need PLSQL, it acts as stored procedures and triggers, and it provides ability to add middle-tier business logic to client-server applications. If you can recall your memory, we discussed about multi-tier database architecture. In that case, this PLSQL provides ability to add middle-tier business logic to client-server applications. And it also provides portability from one environment to another. That is also very important. So when databases has to be ported from one environment to another, Oracle PLSQL provides very useful features. And if you check the performance in multi-query transactions, PLSQL gives you a higher performance, and it provides better error handling by using PLSQL. So advantages of PLSQL, if you take when you do the programming, you will come to know and you will experience these block structures. PLSQL consists of blocks structure for code, and you can have nested blocks within other blocks. Each block can perform a unique task from a logical module, and PLSQL blocks can be stored in the database for reuse. PLSQL also have the capability of procedural language constructs like conditional statements, loops, as I just told you a few minutes ago. And as we discussed, it is giving better performance as well as better error handling. And, if you take fundamentals of PLSQL programs combine SQL queries with procedurals. Likewise, it is a full-featured programming language, and it can be executed using Oracle's utility such as SQL+. It is an interpreted language. I think you have some idea about interpreted languages as well as compiled languages. Therefore, PLSQL is type of interpreted language. We do not want to compile before the execution. The other thing is since you are familiar with some programming, what is case sensitivity is not applicable in PLSQL commands. Therefore, the words of the keywords you are written in capital or simple letter, that case is not considered in PLSQL. But inside the quotation marks are case sensitive. Therefore, capital M and simple M are not taken as equal, which are written inside the quotes. Almost all the programming languages we use today use semicolon to end each command statement. Therefore, PLSQL is also using the same style. It uses semicolon to represent the end of a statement. It also contains reserved words and built-in functions, right? Or you can make use of those functions and implement your logic. Here are some PLSQL command and their style. You can have reserved words. You have to use uppercase letters to write reserved words. For example, begin, declare. All the reserved word has to be written in uppercase letters. It's a best way of writing your PLSQL code. Otherwise, you can't have a clear contrast between keywords and other words and statements you write. And you can have built-in functions; those has to be also written in uppercase. Only the database objects and variable names are written in lowercase. All the others are written in uppercase. That is the way of writing PLSQL statements. So to continue with the lesson, you better have installed in your machine. I think everybody have my file, it's an image file, having the mentioning the version of. You can just search in the internet and download that version and follow the screen instructions to install ThariHasa 11G. And you can give your own password at the end, but keep that in mind. You have to note it down somewhere, otherwise if you forget that, nobody is able to pick up. Right. Do you have any questions? We can wind up today's class. There you can send your attendance, your index number and name. Then you can leave the class.